Hello and welcome. In this training, we will explore how to create, configure, and manage custom security attributes in Microsoft Entra ID. This feature enables you to store sensitive information and enforce granular access control beyond standard directory capabilities. Let's get started. To begin, we must define what custom security attributes are. Unlike standard directory extensions, which are often visible to any user in the tenant, these are highly secure key-value pairs designed for sensitive business data, such as employee clearance levels or project codes. Their primary power lies in their ability to drive attribute-based access control, or ABAC, allowing you to govern access to resources like Azure storage based on these tags. Crucially, they operate under a distinct permission model. Even a global administrator cannot read or manage these attributes without being explicitly assigned the correct roles, ensuring a higher standard of data privacy. This diagram illustrates the separation between standard and custom attributes. On the left, we have standard attributes and directory extensions, which generally have broad red access. On the right, highlighted in orange, are custom security attributes. Access to this path is restricted. These attributes are specifically architected for sensitive data storage and ABAC enforcement, creating a secure enclave within your identity object metadata. Security is maintained through a specialized role-based access control model. You cannot simply use a generic admin account. To define the schema such as what attributes exist and their data types, you need the Attribute Definition Administrator role. To apply these attributes to users or applications, you need the Attribute Assignment Administrator role. Furthermore, viewing the history of changes requires attribute log roles. This granular model supports strict separation of duties, allowing you to grant permission to manage specific attributes without exposing the entire directory's sensitive data. Here we see the role-based interaction model. The admin user at the top cannot directly interact with the system components without specific assignments. They must assume the definition admin role to manage the schema, the assignment admin role to update values on objects, or the log reader role to access audit logs. Each path is distinct, enforcing the principle of least privilege. Configuration starts with creating an attribute set, which acts as a container for related attributes. Think of it like a folder for HR data or project specs. Inside a set, you define the attributes themselves. You can choose data types like string, integer, or Boolean and decide behavior rules. Can a user have multiple values for this attribute? Must the value come from a predefined list, or can it be free text? A critical design consideration is that once an attribute is created, it cannot be deleted, only deactivated. This immutability ensures data integrity for audit trails but requires careful planning before creation. This flow outlines the life cycle of a custom attribute. You begin by creating a set, then defining the attribute within it. Next, you configure the type such as string or integer and set constraints like predefined values. The attribute then enters the active state, where it can be assigned. Finally, if no longer needed, it moves to deactivated, but notice it does not disappear. It remains in the system to preserve historical integrity. As your organization scales, centralized management becomes a bottleneck. Custom security attributes solve this through flexible scoping. You can assign an administrator permissions at the tenant scope, giving them power over every custom attribute. Alternatively, you can assign permissions at the attribute set scope. This means you can give an engineering lead the ability to manage only the engineering attribute set, without giving them access to HR attributes. This capability is essential for maintaining a zero-trust posture, ensuring administrators only access the data relevant to their function. This diagram contrasts centralized versus delegated access. The tenant admin on the top has full access to both HR and engineering sets. Below, we see the delegation model. The HR delegate has scoped access only to the HR set, and the engineering delegate only to the engineering set. The dotted line emphasizes that the HR delegate is blocked from accessing the engineering set, enforcing boundary isolation. Once defined, attributes must be assigned to objects to be useful. You can apply these to users, enterprise applications, and managed identities. For example, you might tag a service principal with a cost center attribute or a user with a clearance level. Assignments can be handled manually in the portal for ad hoc needs, or automated via PowerShell and Microsoft Graph API for bulk operations. When updating multi-valued attributes, remember that you are modifying a collection. You can add or remove specific values from the list associated with an identity. This sequence shows the assignment process. The administrator initiates a request, perhaps using the updateMG user command. Microsoft Entra ID first validates that the requester holds the Attribute Assignment Administrator role. Upon validation, the attribute value is applied to the target object, and a success confirmation is returned to the administrator. The real value of these attributes is realized in their usage. You can use them to filter lists of users or applications in the portal, helping you organize your directory. More importantly, they integrate with security policies. You can build conditional access policies that target specific applications tagged with a custom attribute, such as high impact. You can also use them in Azure RBAC conditions to grant fine-grained access to storage blobs. However, be aware of current limitations. You cannot yet use these attributes to dynamically populate security groups. This flow demonstrates a security enforcement scenario. A user request hits the conditional access policy engine. The policy evaluates the application's attributes. If the application is tagged as high security, the path branches to require phishing-resistant MFA. If there is no match, the flow proceeds with standard access controls, dynamically adapting security posture based on the attribute. Finally, maintaining governance requires robust auditing. Because these attributes often contain sensitive data, their audit logs are segregated from the standard directory logs. You will find them in a dedicated Custom Security tab. To view them, you must hold an attribute log role. For long-term retention or SIEM integration, you can configure diagnostic settings to stream these logs to Azure Monitor. Remember, while you can deactivate old attributes to prevent new assignments, the definitions remain in the system, ensuring that historical log data retains its context. This diagram depicts the auditing workflow. When an admin change occurs, it is recorded in the Custom Security Audit log. When a user attempts to view this, the system checks for the specific log role. If valid, details are displayed, otherwise access is denied. Parallel to this, the logs can be exported to external systems like Azure Monitor or a SIEM for broader security analysis.